Postulates of Thermodynamics. What fundamental properties do we need for our discussion of thermodynamics? And what are the postulates of thermodynamics? Fundamental properties, we have said, are properties that we cannot describe in simpler terms. We are going to assume that we all understand what these mean intuitively, because we must experience them with our own senses to understand their meaning. These properties capture some very essential features of the universe. The first fundamental property that we will postulate is mass. And in postulating mass, we are saying that matter exists. The second one is volume. And volume means that matter occupies space. The third one is energy. And energy means that matter moves and interacts. The fourth property is entropy. And entropy tells us that these interactions between pieces of matter lead to a state of equilibrium. Now, there are other properties as well. So, for example, time is another fundamental property. However, we have not added time to our list of fundamental properties because in thermodynamics, we will only deal with equilibrium states or quasi-equilibrium processes, which are not dependent on time. Temperature and pressure are not fundamental properties. We are going to give definitions of temperature and pressure in terms of the fundamental properties that we have listed. All other properties, such as enthalpy and specific heat, can also be expressed in terms of these fundamental properties. We have already stated 4 postulates, and let us list them all together over here. So the state postulate says that all isolated systems reach a state of equilibrium. The equilibrium state of a pure, simple, compressible substance is completely described by its mass, volume, and internal energy. The first law of thermodynamics states that the change in energy of a closed system equals the net energy transferred to it in the form of work and heat. The second law of thermodynamics states that the entropy of an isolated system will increase until the system reaches a state of equilibrium. The entropy of an isolated system in equilibrium remains constant. The third law of thermodynamics states that the entropy of a pure substance in thermodynamic equilibrium is 0 at a temperature of absolute 0. We can state all of these postulates in mathematical equations. The state postulate is given by the fundamental equation that S is a function of U, V, and M. The first law of thermodynamics is given by the equation that Q plus W is equal to delta E. The second law of thermodynamics is that delta S is greater than or equal to 0 for an isolated system. And the third law of thermodynamics is that S is equal to 0 at T is equal to 0. To summarize, we are now going to develop thermodynamics as a logical system. To do this, we have stated that there are 4 fundamental properties. We have also stated 4 postulates. These are going to be the foundation of everything that we do from now on in thermodynamics. All other properties are going to be defined in terms of these 4 fundamental properties, and we will do that using these 4 postulates.